Welcome to Understand the Math. In this video, I'm going to teach you all about linear functions and models, a fundamental topic in algebra. We'll define what a linear function is, look at a few examples, and then learn how to build equations to model everyday situations. Let's start by talking about what a linear function is. A linear function is any function that creates a straight line when you graph it. A linear function is written as f of x or y is equal to mx plus b. The slope of a linear function is equal to m, and m is just the change in y divided by the change in x. As x changes by 1 unit, f of x changes by m units. You can see this up here in the graph. If x changes by 1 unit, our y changes by m units, and so our slope is our change in y over our change in x, which is m divided by 1, which is just equal to m. Every linear function f of x has a constant rate of change. The rate of change of this function is equal to m, which is just the slope of the graph. A linear function also has a y-intercept, and this is equal to b, and it's just the point where the line crosses the y-axis. Let's now look at some examples of linear functions so that you can understand them better. I have 3 examples listed here, and for each example, we're going to find the slope and the y-intercept. Each of these linear functions is written in the form f of x is equal to mx plus b. Let's look at our first example that's written here in red. The slope of this linear function is equal to m, which is 2. It's just the number that multiplies your x. And then our y-intercept is the number that stands by itself. And in this case, it's equal to 1. If we look at the graph of this function over here on the left, we can see these numbers. Our b is the point where our line intersects the y-axis. And then our slope is our change in y, which in this case is 2, divided by our change in x, which is equal to 1. Let's now look at our second example, the one that's in blue. For this example, our slope is equal to minus 1/2, and our y-intercept is equal to negative 1. And if we look back at our graph, we can see that our intercept is where y is equal to negative 1, and then our slope is the change in y, which is down 1, divided by the change in x, which is to the right 2. So it's minus 1 divided by 2. Let's now look at our third example. Our third example looks different than the other two because there is no m times x. So for this function, our slope is equal to 0, and our y-intercept is just equal to 4. Let's go ahead and let's look at this graph. You can see that our intercept is equal to 4, and we have no slope, which actually indicates that we have a horizontal line. Let's now look at all of these graphs together and see what's different about them. As we move from left to right, we can see that a line that goes up, which is our red line, has a positive slope. A line that goes down has a negative slope. And then a horizontal line has a slope of 0. Let's now put what we've learned into practice and look at some linear function models. A linear model is just an equation that shows a constant relationship between two quantities. A linear model is just this equation, y is equal to mx plus b, where m is our slope, but in the context of linear models, we say that it's our rate of change. And then b, which is our y-intercept, we say is equal to our initial or starting value. We can think of all of these 3 terms like this. Our y can be thought of as our future value. Our m times x can be thought of as how much our function changes. And then the b can be thought of as what is the present value or initial value of the function. We're now going to look at some problems involving a constant rate of change, and I've written down 5 steps that we can follow to solve these types of problems. I often find that students learn best when you can actually follow steps to solve a word problem, because word problems are just challenging. The first step that you can follow is to determine what you actually want to find, and we're going to set that equal to y. The second step is we're going to find the initial value, and that value is equal to b. We're then going to find the rate of change, which is equal to m. We'll next write down the model and put m and b into the model. And then the last step, we'll use our model to find our unknown quantity, which is y. Let's look at some examples now. In our first example, we have a car that has already traveled 80 miles. As we read through this, I'm going to highlight these important parts. So our car has already traveled 80 miles. It then continues its journey at a constant speed of 60 miles per hour. And what we want to do is determine the total distance the car will have traveled after driving 3 more hours. The first thing you want to do when you look at a problem like this is to see what type of rate of change you are working with. In this problem, it says that our car is traveling at a constant speed, which means it's a constant rate of change. And that means that we can use our linear model. So I'm just going to write down we have a constant speed. So that means our model is going to be y is equal to mx plus b. Now let's go through our steps. Our first step is we want to determine what it is we want to find. Looking back up at the problem, it says determine the total distance the car will travel after driving 3 more hours. So let's let y be the total distance the car travels. And then our second step is to find our initial value, and that's equal to b, which is y at 0. So that means, in this case, what is the initial distance? So let's look at the first sentence in this problem. It says the car has already traveled 80 miles. So initially, our car will have traveled 80 miles, so we'll set y of 0 equal to 80. Now let's look at our third step. Our third step says to find the average rate of change, and that's going to be equal to m. And our average rate of change is going to be 60 miles per hour. Our fourth step says to write the model. So we're going to take our m and our b and we're going to put them into our model. So we have y is equal to m, which is 60, times x plus b, which is 80. And then our last step is to find the unknown quantity. In this problem, we want to find our total distance after driving 3 more hours. So that means that x is going to be equal to 3 hours. Let's plug that in. So we have y is equal to 60 times 3 plus 80. And this gives us 180 plus 80, which is equal to 260. And let's go ahead and let's put units with this. It's 260 miles. The last thing that I always want to do whenever you solve a word problem is to actually write down the answer in a sentence. They were asking us to determine the total distance. So let's write down that the total distance traveled is 260 miles. And you always want to make sure that you have units in your final answer. Let's look at another example. In our second example, we have a group that's organizing a day trip to an amusement park. The cost of renting a bus for the trip, let's go ahead and underline that. The cost of renting a bus for the trip is $300. An admission ticket for each person is $25, and we want to find the total cost of the trip if 50 people attend. This problem involves the cost of a trip where each person pays the same amount. That means we have a constant cost for each person. So I'm actually going to write that down here. So we have a constant cost for each person. And that tells us that we can use the model y is equal to mx plus b. Let's now start and we'll go through these steps to solve the problem. The first thing is to determine the quantity you want to find. We want to find the total cost of the trip, so we're going to let y be the total cost of our trip. And then in our second step, we're going to find the initial value. Now, this is a little tricky for this problem. The initial value is actually going to be what we call a fixed cost. And that means it's just the cost that is independent of how many people would attend. So for this problem, that fixed cost is the cost of the bus, which is $300. So we're going to say that B is our y at 0, meaning it has no relation to how many people are going on the trip. So that means x is equal to 0. And that's going to be equal to $300. For our third step, we have to find the rate of change. So we've actually already talked about that. So our rate of change is our m, and it is going to be our cost for each person. Let's write that down. Cost for each person. And that's going to be $25. Our fourth step says, let's write the linear model and let's plug in these values. So we have y is equal to m, which is 25 times x, plus b, which is 300. And let's just make a note that x is the number of people that are going to be going on the trip. Our last step then is to find our value y. So let's go back up and let's look. It says we want to find the total cost of the trip if 50 people attend. Okay, so that's the key. Our x is going to be equal to 50. So let's write that down. Our x is 50, and that means our cost y is going to be 25 times 50 plus 300. 25 times 50 is 1,250, and we're going to add 300 to that. And then we get a total cost. We're going to put units here, $, $1,550. So we can write down that the total cost of the trip is $1,550. You hopefully now have a better understanding of linear functions and models, and you can go on to solve problems like this on your own. Remember, the key is to identify the constant rate of change in your problem.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.